Hello, hi, namaskar everyone. My name is Deependra and I welcome you all to this amazing session of logarithm. Why amazing? Because here, first of all, we'll be understanding what exactly is logarithm. People study logarithm, people solve questions based on logarithm, even without understanding the basics of logarithm or why was this concept introduced. And of course, I welcome you all in this bridge course where we are welcoming all these students who are moving from 11th to 12th standard, where we feel that there is a dire need of understanding these chapters because they are not very well understood by a lot of you and they are very highly used in a lot of chapters at a lot of places. And there, one of those chapters is logarithm. So this is what we'll be discussing in today's session. So shall we get started with this? I hope you all are there listening, understanding and watching this with utmost clarity and understanding. And do remember, in this session, whatever you study, take proper notes, make these notes, and don't worry, all of these notes will be provided to you in the PDF format. These structured, detailed notes will be yours, of course, totally yours. You just need to click on the link given in the description. You can download it from our PW app, or if you visit the website pw.live, from there also you can get these notes. So let's get started with a crystal clear clarity that what all will be covering. We'll be understanding logarithm, then of course we'll talk about characteristic and mantissa, and then we'll understand the properties of logarithm. Then there are certain more properties which we'll discover, and then we'll talk about monotonosity of logarithm, that how does it behave, how does it perform, and then of course we'll be solving certain questions, and while we'll be understanding the graph of logarithm. So this is all majorly we'll be covering. So here, let's get started. Before I explain you this entire theory, I'll simply take you through with one basic concept, which is simply this. Let's say if I talk about higher powers of 2, 2 to the power 1, 2 to the power 2, 2 to the power 3, then you know that 2 to the power 1 is 2, 2 to the power 2 is 4, 2 cube is 8. I hope everyone is listening and understanding. So what do I mean by this basic concept here is that 2 when raised to power 1 gives you 2, 2 when raised to power 2 gives you 4, 2 when raised to power 3 gives you 8. So it gives you 2, 4, 8. What? 2 when raised to certain powers. Now the base is fixed. What do I mean by this? This base 2 over here is fixed in all these three cases. On the basis of this, when I'm raising it to certain different powers, I'm getting certain different values. As we all know that when I raise 2 to the power 4, I would be getting 16. But let's say I ask you a different question, a totally different question. Let's say if I ask you that 2 should be raised to what power so that you get a 10. Now what will be your answer? Did you first of all understand my question? My question is pretty simple. All I'm saying is that we know 2 to the power 1 is 2, 2 to the power 2 is 4, 2 cube is 8, 2 to the power 4 is 16. But here between 8 and 16, there could be a value 10, of course, which when raised as a power of 2 should be getting. But there is a problem. We don't know that number. And humanly, it is impossible to get that number. But with logarithm, we define these numbers. How? Let's have a look at that. How do we define these numbers? All you need to understand is that here, if I wish to define this x, I'll be writing this x as log 10 base 2. Are you getting what I'm saying? Yes. Somebody is writing something in the chat box. Yes, that's brilliant. So all I'm saying is, yes, that's an amazing response. That's brilliant, Pluto. So with that, I hope most of you are getting this clarity that log 10 base 2 means what? This means that when this 2 is raised to this power x, it results into 10. Everyone getting an understanding this part, all the participants. That's exactly what I'm trying to explain here. That here, between 8 and 10, there is 16. And we see that 2 to the power x is an increasing function. It is increasing. As you are increasing the powers, the values are also increasing. Which means between 3 and 4, there could be some value. There could be some value for which when 2 is raised to that value, it will result in 10, but we don't know that value. No worries, it has just started, Mishal. Don't worry about that. So everybody understood that logarithm part. Are we clear on that? That how did they derive? How did they introduce the part or portion where logarithm is needed? For example, here again, if I ask you a question that here 10 should be raised to what power so that it results into 1000. So first of all, in the world of logarithm, how will I write it? I'll be writing it as that log of 1000 at base 10. This is going to be nothing but x. Can you help me with this value? I hope most of you are very clear with this part, that when I ask you that 10 should be raised to what power so that it results in 1000, and I hope you all are very clear that yes, sir, it would be great if you start classes on 7 so that we can hear classes after prayer, the night prayer. I didn't get this part, Akaf. I think you can rewatch this video, the initial part which you might have missed. Don't worry about that. So here, if I could begin with this part, I think it is going to be 3. That's brilliant, Pluto. So with that here, 10 should be raised to power 3 so that it results into 1000. So I hope you're understanding the meaning of logarithm. First of all, I'm trying to make you understand the meaning of logarithm. Are we clear on this part, all the participants? So with that, if I move ahead, or if I now go back to the discussion on logarithm which we were having, all I'm saying is that simple part, that logarithm is technically a concept derived from this concept that a to the power x is equal to b. Let's say this is what we are given. Then this a is defined as base, which is raised to certain power, and it gives you a value, which means if I define it in terms of log, so I'll be writing it as log of b at base a is equals to x, which we read as that a should be raised to a certain power so that it results into b. Everyone understanding this basic definition? First of all, great, perfect, brilliant. That's the best part. So if you have understood this, now there are some constraints. What are those constraints? Let me try and give you more clarity about or on those constraints. So basically, log is used to find the power to a number must be raised to equal number. Exactly. Which is not a perfect square. No, even if it is a perfect square, then also it is fine, Pluto. Then also it is absolutely fine. Now, let us understand one very basic concept. Let's say I'm raising -1 to power 10. It gives you 1. So in the world of log, what happens? In the world of log, what happens is that, sir, here, I hope you're understanding, a to the power x is equals to b. So with that, I hope you're understanding that log of 1 at base -1 will be 10. I hope there is no confusion on that front. But here, I hope you're understanding, even if I take -1 to the power 5, -1 to the power, let's say 8, that is also 1. So do you not think that in that case also, I'll be saying log of 1 at this -1 base is 8. So I think I'm creating some problem in that case. Yes, I'm teaching peacefully and I want you all to study this peacefully. But I hope you're realizing that log 1 at base -1, log 1 at base -1 is somewhere 8 and somewhere 10. So if this LHS and this LHS is same, then RHS should also be same. And if the RHS is same, in that case, you're concluding that 10 and 8 are equal. And I think we are making a blunder here. We are doing a blunder here because 10 and 8 are not equal. And if somebody proves it, then I am making some mistake here. Which mistake am I making here? So somebody is already saying that yes, we cannot take the base as -1 or 1. Yes, that's good. So I hope you're understanding that there should be some constraints imposed here so that we could define logarithm in a more proper manner. Yes, since 1 can be raised to any power, but still it will result in 1. So yes, it cannot be the base. So I hope you're understanding all what I have discussed is absolutely wrong, because this part is absolutely right, but if you take logarithm or if you define log like this, then there are some challenges which we are facing mathematically. So there is certain problem here. Now, if I wish to resolve that problem, all I need is that logarithm, on logarithm, I should put some constraints. So if I try and define logarithm, let me take it from this basic concept here. Let's say I take a function y is equals to a to the power x, where I'm defining a in such a manner so that you understand it more clearly. Let me take any value of a. So let me take a as 2. So this a could be any arbitrary constant, 2, 3, 1.57, but here I'm imposing this constraint that this base here should be positive. Because if this base a becomes negative, then there will be some problem, because I will start getting into imaginary world. I hope you're understanding. Let's say if this base is -2, in that case, if the power is 1/2, then I'll be having some problems. So I hope you're understanding. I cannot have this base as negative. I hope you are clearly getting it. And with the base as 1, there is a problem, as we have simply seen previously. So I think there I got to put some constraints here. So I'm trying to define the function y is equals to a to the power x, but to make it more clearer, All I'm doing is I'm taking this base a as 2. I hope you're comfortably understanding this part. Now with that, all I'm saying is some very basic thing here, that if I start defining 2 to the power x, so I hope you're clearly getting that if I start taking different values of x, so if I start taking different values of x, which means if I take x as 0, yes, so that's the problem. We cannot have base as negative. So let's say if I take x as 0, so 2 to the power 0 is 1, so there will be a point 0 comma 1. If I take base as 1, sorry, the power x as 1, so 2 to the power 1 will be 2, and so on and so on. So I'll be seeing that the power is constantly increasing, and it is increasing exponentially. It is increasing exponentially. So what does it mean? This is how you see the graph of y is equals to a to the power x. Which means here, of course, it will not be a dotted line, it will be a continuous function, which means you need not lift the pen up while drawing this graph, and this will be intersecting the y-axis at the point 0, 1. This is the graph of y is equals to a to the power x. Remember, especially when a, the base is greater than 1. Why did I say so? Because if the base is less than 1, if the base is less than 1, let's say I am drawing the graph of y is equal to 1 by 2 to the power x. Now I hope you understand 1 by 2 means what? 0.5. First of all, we have concluded the base cannot be negative, which means base should be greater than 0. Now we have put one more constraint, that base cannot be 1. I hope you do remember that discussion. So now I am classifying it into two categories, where the base is greater than 1, and second category when the base is between 0 and 1. So let's say if it is 1 by 2. So when 1 by 2 is raised to higher powers, do you not think it will start decreasing its value? Because I have been understanding 1 by 2 to the power 0 is 1. Everyone getting it? But 1 by 2 to the power 2 or 1 by 2 to the power 1 will be 0.5. 1 by 2 to the power 2 will be 1 by 4, that is 0.5. So it is clearly decreasing. But if x decreases, y increases, because 1 by 2 to the power minus 1, 1 by 2 to the power minus 2, 1 by 2 to the power minus 3 will make it, I hope you're understanding. Let's say 1 by 2 to the power minus 1, so it is actually 2 to the power 1, which is 2. 1 by 2 to the power minus 2, so it will be 2 to the power 2, which is 4. So when x decreases, y increases. So I hope you're understanding. I will be seeing its graph to be drawn like this. I hope you're comfortably understanding this. So here I am trying to make you understand the graph of y is equals to a to the power x, but the case when a is less than 1. I hope you do remember it from the previous session only, that this sign here represents for all. I hope there is no confusion on that. For all a which are less than 1. So one thing you got to remember, that if the base is greater than 1, it increases. And if the base is less than 1, it decreases. Decreases means as x increases, y decreases. But you tell me, whatever power I raise it to, a is fixed, the base. Now x can vary. So x can vary from minus infinity to infinity. Whatever value I give it to, do you not think it can never be 0? And the worst case will be that it can never be negative. Are you understanding this language of this part? All I'm trying to make you understand is that here, whatever base you take, of course, base now we have defined will either be from 0 to 1, or base will be greater than 1. So we have gotten this conclusion that base can never be negative, and it can never be 1. Now one conclusion is that base will lie either from 0 to 1, or it will be greater than 1. So with that conclusion in mind, if I raise a this a is raised to any power, which means there this x can be any real number, which means this x is any number from minus infinity to infinity. Do you not think that this a raised to any power will always be positive? I'm not even saying non-negative, it will always be positive. You raise it to any power. Let's say I take 2. Now you tell me, or you give me any power of 2. You take any negative power, you take power as 0, you take any positive power. Do you not think it will always be positive? Because 2 to the power minus 2 is 1 by 2 square. 2 to the power 0 is 1. 2 to the power 5 is 32. So whatever power you are raising it to, it will always be positive. It can never be negative. What does it mean? It means a to the power x, which is y. So this y is always positive. So second conclusion, first conclusion regarding a which we have received, I hope you are getting it very clearly. Second conclusion regarding y, that a to the power x is y, which means this y is always positive. Y means a to the power x. And third conclusion regarding this x, that this x could be any real number. Did you get that part? Now with that, now I lay the foundation for logarithm. What do I mean by that? Now, if I am willing to define logarithm, so first of all, we had a to the power x, which was y. How do we define it in terms of logarithm? So I'll say, sir, log of y at base a will be x. Log of y at base a will be x. I hope from there you do remember that here what did we discuss? What did we discuss? Sir, a should be greater than 0 and it cannot be 1. So there I hope you remember that a should be greater than 0 and it is never 1. Do you remember that? What did we discuss regarding a? Sir, x can be any real number. I hope you do remember that. This sign here, this sign here, this sign here, this sign, let me draw it more properly. Here it means belongs to. So x belongs to any real number. I hope you remember that from the last session's discussion. And the third value here, which we did discuss, is what? This value y. And I hope you clearly remember y here will be taking all the positive values only. So these three conclusions, I hope you're comfortable with this. Now here, if I wish to define log x base a in terms of y, I hope you are getting it more clearly now. Log x base a in terms of y, because usually what we keep is in functions, the independent variable is x and the dependent variable is y. So y is dependent on x. So x will start taking different values and I'll start getting different values of y. I'll just try and make you understand with one of the examples. Let's say if I take base a as 10. So let's say if I'm trying to define y, which is log x as base 10. So if I start defining its graph, I hope you are clearly understanding. If I start writing or drawing its graph, I hope you are first of all understanding. When, let's say, I hope you remember this x means what? The value whose log we are taking. So this value whose log we are taking, I hope you do remember from the last slide only, the value whose log we are taking is always positive. So here first conclusion should be that this x will always be positive. Second conclusion, that this base is always positive and it is never 1. The third conclusion, which I need not tell you, y, here y, what is y? It is x, which was there in this last slide, and x could be any real number. So this x is now y, so this y could be any real number. So this y could be any real number. Everybody with me on this, all the participants. Now with that, what do I conclude? I hope you do understand that if now I start trying different values of x, let's say if I take x as 10, 100, 1000, 10,000 and so on, I hope you're getting what will I start getting. So let's say if I take x as 10. So 10 is raised to what power so that I get 10? So it should be 1. Can you help me with that answer? So here log 10 base 10 will be 1. So I hope you're understanding when I draw its graph, its graph will be drawn like this. Why did I say so? Because here, please understand, here this will be a point where what point is this? I hope you're understanding. It is 1, 0. It is 1, 0. So I hope you're understanding 1, 0 means what? Log 1 at base 10. So I hope understanding 10 should be raised to what power so that it results into 1. So sir, anything raised to power 0 is 1. I hope you remember, except for 0. So if 10 is raised to power 0, it will be 1. So if log 1 at base 10 is asked, the value will be 0. Are you getting it very clearly? So let's say if I ask you log 10. So if I ask you log 10, so log 10 base 10. So 10 should be raised to power 1 so that it results into 10. So log 10 if I find, so there will be a point 10, 1. So I hope you're understanding how will these points be plotted. So this is simply nothing but the inverse of a to the power x. So first of all, I'm trying to build this image here that here, if there is a function a to the power x is equals to y and there is a function log x at base is equals to y, they are inverse of each other. Sir, we don't understand what is an inverse function at this stage. Yes, I totally get this. You have cleared 11th standard so far. And when you study the chapter from calculus, the first chapter, which is functions, there will be defining the inverse function. There, I'll make you understand it more clearly. And there, I'll give you a better explanation that why are we having this graph like this. And you will start getting understanding that yes, this is exactly how the graph should be drawn. All I'm saying is that here at this stage, if you could remember that if I have stated that a to the power x is equal to y and y is equal to log x at base a, if I am claiming that they are inverse of each other, then always remember for inverse function, what always stays true is that if this is y-axis and x-axis and if there is a straight line, if there is a straight line, which is y is equals to x, then inverse functions are nothing but the mirror image of each other with respect to the line y is equals to x. What does it mean? Do you remember the graph of y is equals to a to the power x? Do you remember the graph of y is equals to a to the power x when a was greater than 1? So simply take the mirror image of this graph with respect to this line. And if you are taking the mirror image of this curve with respect to this line, it will go like this. So this is nothing but log x at base a is equal to y. Where again, don't forget that base is greater than 1. So are you getting it more clearly? Is inverse function that if a gives b using function, then b will give a? Yes, that's exactly what I'm trying to make you understand. But in a more detailed manner, we'll be exploring it. But did you all get this concept? Just give me a quick update in the chat box. With that, can you help me with the graph of a to the power x in log x base a when the base is less than 1? If you can, then try and draw it in your sheet in the notebook which you're carrying right now while watching this session. I hope everybody understood my point. All I'm saying is that, let's say you do remember that here, if this is y-axis and this is the x-axis, and if I ask you to draw the graph of a to the power x, I hope you do remember this is how you draw the graph of a to the power x. Everyone with me on this? But this is the graph of a to the power x when a is less than 1. Do you remember that, all the participants? So here you will be having the straight line y is equals to x passing somewhat like this. So do not confuse you with this line. All I'm saying is that if this was the graph of a to the power x, please remember, if I ask you to draw the graph of y is equals to log x base a when a is less than 1, then this is how this is drawn. Okay, great. This much is enough for chemistry. I'm glad that I could help you with that, and I hope all the other participants who are watching it right now are also clearly getting the basics of logarithm. And are you clearly understanding the concept of log now? All the participants. Here, two more things you should put your focus upon because it is going to be amazingly crucial for you, that this was the graph of log x. So I'm just trying to give you more clarity here that I would need it more here, that this is the graph of y is equals to log x at base a, especially when a is greater than 1. Now, why am I saying this? I am stating this because log x when base a is greater than 1 is an increasing function. Increasing function means a very basic concept that here, if I take two values, let's say x1 and x2. So for x1, this would be the value which will be log x1 at base a, and at x2, this will be the value which will be, of course, this, which is going to be log x2 at base, log x2 at base a. Now please pay attention, if I call it y1 for a while and if I call it y2 for a while, then we clearly know that if I go ahead up on the y-axis, then I'll start getting the larger values. I hope you clearly see that x1 is less than x2, and I can clearly see y2 is greater than y1 or y1 is less than y2. That's why I'm saying that as x increases, y also increases on the graph of log x base a when a, the base, is greater than 1. I am stating this point very clearly here to make you understand that when we solve inequalities based on logarithm, there you got to remember this result. This result will be using in a very clear manner here. Now, the second property is this one, which we have already discussed. If I talk about this graph, this is clearly a strictly decreasing function, which means if I take two values of x, let's say this is x1, this is x2. So here for x1, this will be y1, which is log of x1 at base a, and here at x2, if I take this value, this is your x2, log of x2, which is, let's say, y2, log of x2 at base a, which is your y2. Everyone comfortably understanding this? Now I hope you clearly see on the x-axis, x1 is on the left hand side, x2 is on the right hand side, so x1 is less than x2. But here on the y-axis, it is up, it is below, which means y1 will be greater than y2. What does it mean? Sir, x1, I hope understanding, was lesser, but log x1 is greater. Sir, x2 was greater, but log x2 is lesser. So this clearly indicates that this is a decreasing function. I hope you can see the graph as well. But when is it becoming decreasing? Especially when the base is less than 1. So you got to remember this property, because based on this property, we'll be solving a lot of questions. Everybody getting that? All the participants. Can I move ahead from here? Yes, good to have you all. Then when I move ahead from here, let me get back to the discussion we all were having regarding logarithm. This is exactly what is written over here. So all what is written over here is this, except for the one thing, that here, if I ask you to talk about one more base, which is the natural base, which is called the Napier's base, because Napier was the mathematician who developed, who invented or who discovered logarithm, and he gave this magical number, which is an amazing number, 2.7182, and it goes on because it is an irrational number, and with that you get something really amazing. Of course, we'll talk about the wonders which it creates, but remember, this E is a fixed number, a reserved number, an irrational number. For example, pi is reserved for 3.14 and so on. Similarly, we have this Napier's constant, which is 2.7182 and so on. Will you remember that? So I hope so far whatever we have discussed, you don't have any confusions on that, and we can move ahead with that part. Everybody with me on this? Everybody understood that part? So remember one thing, if it is base 10, it is natural log, and if it is base E, it is Napier's constant. Everybody with me on this? All the participants. Now with that few values you should keep with you, which are going to be this, that log 2 at base 10 is going to be 0.3010. This is what you would be needing in chemistry as well. So please remember that. So yes, hello Omomore, hello, hi everyone. And if you talk about log 3 at base 10, it will be 0.4771. These two values you should mug up, you should by heart. Yes, do remember if I write ln2. So what is ln2? Conventionally in mathematics, if I'm writing ln2, it means log 2 at base E. So two things are there. If the base is not defined, let's say if I write it as log 10, then always remember it means log 10 at base 10. So if base is not written, conventionally the base is 10. The way we do with root, let's say if this is square root of, let's say 5. So what does it mean? There is 2 written over here, which means this is the second root of 5. So if it is second root, which means a square root, we don't write any number here. But if it is third root, fourth root, then we write 3, 4, etc. That's exactly as with logarithm. So if there is no base written over here, we take or consider it as log at base 10. And there, if it is ln2, then it means log of something at base E. I hope you'll remember these basics. I hope there is no confusion on that. And these two values, I'm clearly instructing you all to remember or by heart. Don't miss them, because these two values you will not only require in maths, but more importantly, you will be needing these values in chemistry. So they expect that you remember or by heart or memorize these two values, because they are used a lot in chemistry specifically. Can I move ahead with this? Now, when we talk about further about few more things, then I talk about this corollary. This is technically the fundamental logarithm identity. What does it mean? It simply means that we know, let's say if I ask you 2 to the power 5, if I ask you 2 to the power 5, then what is it? It is 32. Everyone with me on this? So if I define it in terms of log, then we say that's a log of 32 at base 2 is what? So I hope you're understanding. 2 should be raised to what power so that it results into 32. So I hope you do remember it is always 5. Everyone with me on this? So here what I'm trying to tell you is that pay attention to this part. A raised to the power log b base a. A raised to the power log b base a, which means what? That 2, let's say, is raised to the power log 32 at base 5. Sorry, at base 2. Then what will it mean? What would it mean? Can you help me with this? I hope you are understanding all what I'm asking you for, that what would it give me? Is it not the same property? Because here, what is it asking? See, 2 when raised to power 5 gives you 32. 2 when raised to power 5 gives you 32. Everyone understanding this? So here, what are we asking? Sir, 2, this 2 is raised to a certain power. Okay, perfectly fine. Then pay attention to this part. Forget this 2 for a while. 2 is raised to what power so that it gives you 32? I repeat, 2 is raised to what power so that it gives you 32? I think that's exactly what they are asking you. 2 is raised to what power so that it gives you 32? So log 32 base 2 is that power only. So 2 is raised to that power only. And if 2 is raised to that power only, That means it gives you a 32 here. Did you understand what I have just said? The fundamental property of logarithm. If you did not, do write in the chat box. I'll re-explain this part in a more clearer manner. If you could understand my words more clearly, this is one of those properties which is phenomenally, which is exceptionally and very largely and very widely used in mathematics. Not only in questions of logarithm directly, but indirectly or subtly in a lot of other chapters as well. In calculus, in quadratic, in sequence and series, in a lot of other chapters, matrices, determinants sometimes, vectors in 3D also could use it. So they use it at a lot of other places. So first of all, do tell me, did you understand this part? How we recommend or prescribe students to remember it? What we say is that here, whenever you see that this base and this base is same, then you write this as the answer. Did you understand what I'm saying? All I'm saying is a pretty simple word. Let's say here, if you are given that a to the power log of, let's say, 7 at base a. So this a is raised to this power. I hope you're understanding this expression first of all. This a is there. This a is raised to this power log of 7 at base a. So what I'm asking you to notice here is the simple result, which means that if this a and if this a are same, if this base to which this whole thing is raised to, which is log 7 base a, and the base of logarithm is also same as this base, then simply forget everything and write this value as the final answer. Will you remember this result? That's good, Rags. I hope all the other participants also who are watching it right now have understood it very clearly. Will you remember this fundamental property or identity of logarithm, which is derived from the basic definition of logarithm only if you are paying attention to that. Now from here, that's good on. Now from here, I hope this is what we have already discussed, this particular part, which we have already discussed through the graph of logarithm. Now that's exactly what I'm trying to make you understand. This is exactly what I'm trying to make you understand through the graphs of logarithm. See, when the base is greater than 1, when the base is greater than 1, for example, 5 is clearly greater than 1. So greater power of 5 will give me the greater value. 5 to the power 2.7, 5 to the power 2.5. So between 2.7 and 2.5, which is greater 2.7. So 5 to the power 2.7 will be greater than 5 to the power 2.5. But I hope you do remember, if the base is less than 1, if the base is less than 1, 1 by 5, it is less than 1. So now the greater value, greater power give me the lesser value. So 1 by 5 to the power 2.7 will be smaller than 1 by 5 to the power 2.5. How or where do we see its proof? I hope you go and watch the part of this video where we just discussed the graph of a to the power x. I hope you do remember the graph of a to the power x, the graph of a to the power x when a is greater than 1, the graph of a to the power x when a is less than 1. And this clearly lays the foundation for logarithm, because log is inverse of y is equals to a to the power x. Do you remember that? So that's exactly what I've tried explaining to you all. I hope you do remember this result. Not just that, few more results. What does it mean? Look at this part. This is something which we will be using not only here but in limits as well. So do remember this. This will be used. Now what does it mean? It means few things very clearly, that let's say when a is greater than 1, when a is greater than 1, I'll simply try and plot the graph of log x. So I have to remember, this is the graph of log x. This is the graph of log x at base a when a is greater than 1. Do you remember that? So all I'm trying to make you understand is that please pay attention to this part when x approaches infinity. So I hope you're noticing that this graph is also approaching infinity. This graph is also approaching infinity. Which means what? If there is a number which is greater than 1, let's say if there is a number greater than 5, and if it is raised to the power infinity, then it will be approaching infinity. Did you or were you able to digest what I have said? All the participants, everyone able to comprehend what I'm trying to make you understand here? But pay attention to this part, pay attention to this part. If let's say x approaches 0, I hope you're understanding, if x approaches 0, because this is the lowest value of x which can take. So if x approaches 0, your curve approaches minus infinity. I hope you are clearly getting what I'm trying. I'm really sorry, I have made an error here. Let me not explain it with the graph of log x. I'll try to explain it with the graph of a to the power x. I'm really sorry. I'm really sorry. I am really sorry. I'll try to explain it with the graph of a to the power x. So this is the graph of y is equals to a to the power x. I'm really sorry. I have taken a wrong example here. I'll be more clear with this. A to the power x is what we are discussing now. So here, this is the curve a to the power x. So I repeat, when I talk about 5 to the power infinity, so the base we are taking as 5. So let's say this is the graph of 5 to the power x. So what I'm trying to make you understand is, let's say if x approaches infinity. So if x approaches infinity, so when x approaches infinity, this curve clearly approaches infinity. So when 5 to the power infinity is what I'm trying to find, it will be an amazingly large value. Everybody getting that conclusion, all the participants. Now, when I talk about the second result, which means what? Sir, the lowest value of this x could be what? Sir, I hope you're understanding x can take any value. So the lowest value of x could be what? Minus infinity. It can achieve the least values minus infinity. So when x approaches minus infinity, where does this curve go? I hope you are seeing this curve is going towards 0. So what does it mean? It means, let's say if I'm asking you to figure out the value of 5 to the power minus infinity, in that case, it will be approaching 0. It will be approaching 0. So as x decreases, 5 to the power x approaches 0. As x increases, 5 to the power x approaches infinity. Are you all able to digest my words very clearly, all the participants? But here the case is different. The case is absolutely different, totally different if the base is from 0 to 1. Why? Because you will clearly get the case when you draw the graph of this a to the power x, the graph of a to the power x when the base is less than 1, or rather the base is from 0 to 1. I hope you are clearly getting the case now. Can you help me that here, in this case, when a to the power x is being talked about, and if x is approaching infinity, what will happen? I hope you're understanding, when x is approaching infinity, I can see this curve is going down, down, down like this, and this is approaching 0. So when x approaches infinity, when x goes towards infinity, a to the power x approaches 0. Are you clearly understanding this part? But with that, one more conclusion you got to have here is that here, if x approaches minus infinity, if x approaches minus infinity, which means limit x approaches minus infinity, I can write it like this. Mathematically, this is how we write it. In that case, a to the power x, I hope you can see this graph going up, up and up, which means it is approaching infinity. So this will be approaching infinity in that case. Are you getting my words very clearly? No droppers shouldn't, but if they are weak at maths, if they find logarithm is something which they should get more clarity on, then of course, Victor, you should. If you think that logarithm is something where you should have more command, then of course, I'll be taking you from scratch. I'll be taking you from base. So this is especially for the students who are moving from 11th to 12th. The kind of topics we are doing in this bridge course are those which are useful for the students, which they will be needing in 12th as well, which they might not have studied properly in 11th standard. So that's the motive here. I hope I have made myself clear, Victor, on this. So I hope you got this point very clearly. That's exactly what we are explained over here. So now if I talk about log, in terms of logarithm, if I discuss this point, what do I mean here? I hope you are clearly getting the next part which I'm trying to explain is that, let's say if base is greater than 1. If the base is greater than 1, you see the graph of log going like this. This is the graph of log x at base a is equal to y when a is greater than 1. In that case, I hope you are paying attention to this part, that if log is approaching infinity, then this, I hope you're understanding, when x approaches infinity, then I hope you're understanding y also approaches infinity. But pay attention to the next part, very, very, very crucial, where if x approaches 0, then please remember log approaches minus infinity. That's exactly what you have written over here. Everyone with me on this? And opposite of this will be done when the base is from 0 to 1. I hope I need not explain that part. Can you visualize that by yourself? All the participants who are watching it right now, do give me a confirmation in the chat box. Everybody got that? That if base is from 0 to 1, opposite will start happening. All the participants. So with that, when I move ahead towards the next conclusion, this is what we need to now have clarity upon, whatever we have. Log is simply abbreviation of logarithm. And how do we use it? You do remember E is your Napier's constant and 10 is your natural log, the base. And of course here, which is also known as the base 10 is known as Brick's logarithm as well. There you remember few things, that here A can never be 1 or negative, the base, which we have already discussed. And this is something you got to remember from the graph only. Don't try to claim it, just remember the graph of log x. So if base is greater than 1, this is how you draw the graph of log x. That's good. So with that, we remember that this point is 1 comma 0. So this is the point which divides log, because after 1, all the values will be giving me the values of log x to be lying above the x-axis. Between 0 and 1, all the values will give me the values below the x-axis, which means these values will be negative. So if you talk about log x base a, pay attention to this part which I'm mentioning here. It will be, I think it is oppositely written, because this is wrong, this data is wrong. If base a is less than 1, this should be corrected here. Let me just correct or rectify it. There is a small mistake here. Let me just make that correction here, students. So if the base a is less than 1, in that case this will be true. I'll draw it and show it to you. Let's say if there is base a which is less than 1. So of course for the base a also, this point of intersection of this curve log x, this curve which is log x at base a, this when a is from 0 to 1 will be a decreasing function. So will you make a one shot on conic? Rags, I have already created. It did not get released. But yes, possibly there with these sessions we are trying to help you with that. Rags, do tell me, where are you from? I mean, in which standard you are right now? Victor is saying I'm kind of weak in logs. So yes, in that case, go ahead with this video. You should watch it. Now, when I go ahead with this discussion we are having right now, pay attention to this part. Log x base a, when base is from 0 to 1, this is how the graph looks like. Now, pay attention to this part. When you see x to be lying between 0 and 1, so when x is from 0 to 1, the graph is above the x-axis. So if the graph is above the x-axis, which means it is on the positive side of the y-axis. So there, when x is from 0 to 1, f of x, which means log of x, will be positive. At 1, we clearly see it to be 0. So when x is 1, log of x will be 0, log 1 will be 0. The third conclusion, when x is from 1 to infinity, when x is taking any value greater than 1, the graph of log x is below the x-axis, which means it is on the negative side of the y-axis, which means if x is greater than 1, log of x will be negative. But yes, the condition is the base will be less than 1. Sir, if base is greater than 1, in that case, what will happen? Opposite. From graph only you can now judge it, conclude it, or come up with the right assumptions, and not assumptions, the conclusions. Now with that, I hope few more properties you got to have in your mind is that log 1 at any base. The base is of course greater than 0 and not 1. This I'll not be mentioning again. I have mentioned it a lot many times. Now it should be there in your brain. This base, whenever it is mentioned, it will always be greater than 0 or it will never be 1. Did you get that? Now here you got to remember this part, that log 1 at base a is 0. Why? Shall I explain this? Log 1 at any base is always 0, because this base when raised to the power 0 gives you 1. Everybody got this conclusion, or shall I repeat this part, all the participants? Can I move ahead from here? I hope no more further conclusion should be given. This part also I'd like to explain, log a at base 1 by a. Here shall I explain this? So here when I'm talking about log a at base 1 by a, I hope you're understanding. Let's say I'm writing it as x. So here all I'm saying is that 1 by a when raised to the power x is giving you a. So I hope from here only you're clearly understanding that, sir, if this 1 by a is raised to the power minus 1, it will be a. So log a at base 1 by a will always be minus 1. This is clearly understandable. So I hope you're understanding this value of y can be from minus infinity to infinity, but this value of x will always be positive, and the base always positive, not even 1. Sir, I'm in 11th, now just finished 10th. CCSE, if you remember, I joined your full calculus live stream and I was the one who had finished full calculus and vectors using your videos before 11th standard. Yes, I do remember, Rags. I do remember. And I cannot believe this. And were you able to understand all of that, which we discussed there, calculus and vectors in 3D especially? Thank you so much for being there, first of all. You know, after clearing 10th only you did that. Amazing, that's brilliant. But I hope all the participants are clearly getting what I'm explaining here. Great, that's good, Rags. Now, I'll definitely be releasing a lot of videos. We'll be doing a lot of activities on YouTube as well, not just in our paid batches, Arjuna, Laksh and Prayas. Arjuna, which is for 11th standard students for preparing for JEE. Laksh for students who are in 12th standard preparing for JEE. And Prayas for the dropper ones, as Victor is saying, for the students who are preparing for JEE. Don't worry, we'll be doing a lot of activities on YouTube as well to help you with your JEE for the next year. And of course, so moving ahead with this, yes, so I hope I have cleared your doubt, Rags. Now, can you help me with these questions? Can you help me with these questions? Anyone? So I'm giving you 5 minutes time. It is, I think, 6:45. I'll be coming back at 6:50. So by 6:50, you should be answering these questions. So this is your assignment. I'll be coming at 6:50. This is your assignment which you got to, which is, let's say, your homework. Homework, what should I say? This is the kind of questions which I'm giving you. Solve both of these questions. Write the answers in the comments. Write the answers in the comments. And then we'll see how many of you have understood whatever I've explained so far. So I'll be checking your answers at 6:50. Let's see how many of you get this. Okay. Okay, so that's good. That's good that you have solved. Integration is where you need more practice. Great. So I hope some of you must have tried these questions. Students complain a lot that I don't give them much time to practice or solve the questions. So let's solve this question together. In mathematics, you got to have speed, because I hope you must have seen the analysis which we are conducting. In JEE, the only problem is chemistry is the easiest, which you solve in 30 to 40 minutes. Physics is the moderate one, which takes, let's say, sometimes 1 hour at most in the worst case. And maths, it goes beyond your limit. It is somewhere around 1 to 1.5 hours it takes usually, and in that span also you are hardly able to solve 10 to 12 questions in the best case scenario. That's the nature of this subject. So there you got to have the speed, and that's exactly what we are expecting and hoping for. So if I ask you to solve this question, has anyone done this? So log of, this is given as log of, let me just copy this because I'll be solving it for the next question as well. So if I get back to this, here we are. The first question we are solving. So this is log of 27. Can you help me with 27? I hope you do remember. 27 is 3 cube. So let's say I don't know how to solve this. I'll say 27 root 3 at base 1 by 9. And if I take it as x, because this is the value we are interested in. So by the basic fundamental understanding of log, what will I say? That, sir, 1 by 9 to the power x should be equal to 27 root 3. So here I'll say 1 by 9 whole raised, although you can use the basics of logarithm as well, but since I'm hoping and assuming that you don't know the properties, how do we solve this? So this is how I'm trying to help you with that. So this is 27 root 3. Now 27 is 3 cube. 27 is 3 cube and root 3 is 3 to the power 1 by 2. So 3 plus 1 by 2. I hope you are getting it. When bases are same, powers are added. So it is 6 plus 1, that is 7 by 2. So here it is 3 to the power 7 by 2. Everyone understanding this comfortably? Now with that 1 by 9 to the power x, this is 1 by 9 to the power x. Can I write 1 by 9 is 3 square to the power x? Now 3 square, if I bring in the numerator, it will be 3 to the power minus 2. So it will be 3 to the power minus 2 to the power x. A to the power m whole raised to the power n is a to the power mn. So it will be 3 to the power minus 2x. So when bases are same, both are positive. If I wish to compare the powers, I can directly compare them. So minus 2x will be 7 by 2. And with that, I'll say that x is minus 7 by 4. Everybody got this? That's great, Rags. What about the other participants who are watching it live? Did you get the answer? Let's solve the next question. How many of you got the answer to this question? The moment you see 5 minus 2 root 6 and 5 plus 2 root 6, something should be there in your mind. Again, if I wish to solve this, let me call it x. I'll use the basic understanding of logarithm. That means this when raised to this power should result into this, which means 5 plus 2 root 6 when raised to the power x should be giving me 5 minus 2 root 6, the basic fundamental property of logarithm. So to compare them, I don't have much information. Can I first of all, rationalize this part? So if I multiplied by 5 plus 2 root 6 in the numerator and 5 plus 2 root 6 in the denominator, will I get something decent out of this? I hope you are seeing and paying attention to this part. So here LHS remains that 5 plus 2 root 6 whole raised to the power x, which I'm not touching at all, keeping intact. But here if I talk about the RHS, a plus b into a minus b, that's a square minus b square. So 5 square will be 25, and b square 2 square into 6. So that is 4 into 6, which is 24 divided by 5 plus 2 root 6. Everyone understanding this comfortably, all the participants? 25 minus 24 we all know is nothing but what? 1. So 1 upon 5 plus 2 root 6. If I wish to take it in the numerator, what will I do? I'll say 5 plus 2 root 6. I'll say 5 plus 2 root 6 should be raised to the power minus 1. So here I hope you are understanding base are same. Again, non-zero, not even 1. So here powers can directly be compared and x will be minus 1. So with this basic fundamental of logarithm, that understanding we have on the basis of this is how I'd like to answer these questions. If you don't know any property of logarithm so far, this is how we'll be solving them. Of course, when more properties come into picture, you will not require this much calculation. You will do it more properly, more quickly. How? We'll learn them. And that's exactly what we'll now start exploring. Can you help me with the answer to this question? Quickly, participants. The moment you see this, write the answer. Log 1 at any base is 0, right? That's the answer. Log 1 at any base is 0. So that's the answer. But what if I say that this is absolutely wrong? What if I say that this is absolutely wrong? Why? Can somebody help me? Why is 0 a wrong answer? And in that case, sir, if 0 is the wrong answer, what should be the correct answer? Can you help me with the correct answer in the comment box? Anyone? Quickly, anyone? I hope some of you might have noticed that, sir, there is a catch, there is a problem in this question, that here, when you look at the base, it is sine square theta plus cos square theta, which is an identity, which means sine square theta plus cos square theta is 1, which means the question is log 1 at base 1. So there is a problem in this question. What is the problem? That, sir, the base is 1, and we know the base can never be 1, which means the question is wrong. This question is wrong. So there cannot be any answer to this question. This question is wrong. So if you ask me the question here, there will be no value of this. This is not even defined here. That's phi. That's good. That's good, student. I cannot pronounce your name correctly, but here that's brilliant. Just tell me your name. I'll be really happy if I could know your name. Somebody who has said phi will be the correct answer. Brilliant. Perfect. With that, when I move ahead with the few more conclusions I'm going to bring here, characteristic and mantissa is what I wish to talk about. If I simply take you towards this, when you talk about log table, which is developed by mathematicians, of course, when you look at log table and when you find the values of log, let's say if I talk about log, let's say log of 564 base 10. So it is given at it is given as 2.751279. So here remember this integral part which is before the RF, that's good RF. So this integral part which is before the decimal is called the characteristic of that log n. And here, great Bharat RF, in that case, I am of course, you have my best wishes, and in that case, you will perform exceptionally well if you have done sufficient practice. Let's see you, and don't forget to watch our live analysis, which we'll be conducting tomorrow. So the moment you have attempted the paper, come to our live. We'll be discussing your paper only, and do tell us which questions you have gotten right and wrong. And with that, let's meet tomorrow as well. So here, if I talk about this part, which is the after the decimal. So after the decimal sign, this is the decimal part. It is called the mantissa of this log. I hope you're getting it. Sir, why are we discussing characteristic and mantissa here? How do they help? Now, pay attention to this part. Characteristic and mantissa are, first of all, very amazing. They give you some really insightful details about a value or a number. But if I talk about characteristic and mantissa in a more clearer manner, remember, our job is always to keep the mantissa to be positive. Mantissa can never be negative. What does it mean? Let's say if there is a number log of 0.00895 and its value is given by minus 2.048, something like that. So I can write it as minus 2 minus this, which means characteristic is minus 2 and mantissa is negative of this, which is wrong. You always got to keep the mantissa as positive. Mantissa should always be positive. So if mantissa is meant to be kept positive, what I'll do here is, if I subtract 1 and add 1. So if I subtract 1 here, so minus 2 minus 1 will be minus 3. Plus 1 minus this. So it will be minus 3 plus something. It will be minus 3 plus something. So technically, log of this is this. But in terms of characteristic in mantissa, I'll say minus 3 will be the characteristic and this 0.95 will be its mantissa. Give me a quick update on this. Everybody understood this part? I hope you are understanding why is it important to keep the mantissa positive. Because with the characteristic, you get a lot of insights about the number. What insights? Now let's talk about that. If I quickly take you back towards this number, look at this number, look at this number. Log of this 564 was 2 point something something. What was the characteristic here? So the characteristic was 2. So log of a number has a characteristic 2. That means this number will always have digits 2 plus 1, that is 3. 564. Did you understand that part, or shall I repeat this? Although there is a logical explanation behind this, I'm not getting into that detail, which you can understand when you take or understand the concept of log, which is at base 10. I hope you're understanding when I talk about log, when I let's say talk about log of 10,000. Of course, it is at base 10, so it will be 4. I hope you're understanding it very clearly. So here, 10 to the power 4 is 10,000, which means what? Log of this number, 10,000, has characteristic as 4. So that characteristic plus 1 will be the number of digits here. That is always going to be true. Are you not finding it very amazing? And why is it happening? Because the base is 10. So let's say if ever I give you a number, let's say log of n at base 10. So base should always be 10. That's the constant here. So if the base is 10 and if I tell you that this has certain value, something point something, but its characteristic is let's say 7. Its characteristic is let's say 7. Yes, I'm explaining that part only. Let's say its characteristic is let's say 7. In that case, please remember the number of digits in n will be 7 plus 1. Did you understand that part? Regarding characteristic and mantissa, all the participants, give me a quick update on this, or shall I repeat this part? Just give me a quick update in the chat box. Everybody able to digest this? Rags as well, all the participants. I hope first of all, characteristic and mantissa, this part before the decimal is characteristic, part after the decimal is mantissa. But mantissa can never be negative, which means let's say if there is a number whose log is this, then minus 2 you may treat as characteristic plus negative of this you treat as mantissa, then it is wrong. Mantissa should always be kept positive. So to keep this expression positive, I add and subtract 1 here. With that, this becomes minus 3 and this becomes positive. So which means minus 3 plus something, which means minus 3 will be the characteristic and this decimal part will be the mantissa. First of all, did you get clarity on this? That's good, Leo God. Why do you guys not keep your names properly? Leo God and then Rags, Bujji. What are these names? Why do you not keep your names properly? I mean, I'm not able to pronounce these names correctly. So with that, when I get back to the discussion we are having, I hope one conclusion you have received. Second conclusion regarding characteristic only, pay attention to this part as well. This is again very amazing, very amazing. Here, I'll reveal that part with this property which I'm trying to show you here. Look at this number as we have just discussed this one. Log of this number, let's say I'm taking log of this number. I hope you're understanding this part very clearly. So log of this number here has characteristic as 2. Characteristic as 2. So in this number, of course, it's integral part I'm talking about, not I'm not talking about the decimal part. So its characteristic was 2. So 2 plus 1 will be 3. So there are 3 digits here in its integral part. I'm not saying the whole number will have 3 digits. No. Decimal part we cannot work upon, but here integral part will have these digits. One more than the characteristic. Everybody understood that part? All the participants, everybody with me on this? Now the second conclusion. There is one more conclusion based on characteristic, and that is also a very amazing conclusion. What is that? Let's say there is a number. There is a number. Usually when you define log and let's say its characteristic is -5, which is -5, you usually write it as 5 bar. Technically, this number would have been log, of course, 0.0000279. So it will be written as -5, which is its characteristic, plus 0.4456. So that's its mantissa. Mantissa is not very useful, but characteristic plays a very crucial role. First of all, are you understanding? It is -5 plus this. It is not -5.0 -5.444. No, it's not that. It is -5 plus 0.44. So the number is actually something different, which is -5 plus that number, which will be -4 point something. First of all, are you making some sense out of this? But if I write it as -4 minus something, in that case, I'll get characteristic, mantissa as negative, which we cannot keep. So here, to keep mantissa as positive, I have written it like this. Yes, I do remember. Great. Thank you so much. Thank you so much for your kind words. We really appreciate that. And we'll hope to see you somewhere in future. We'll definitely hope to see you someday in future. Good to have students like you. Now with that, I hope when I get back to this discussion here, by the way, what was your name? What is your name? With that, I hope you're understanding. This is how you write the log of a number if it has the negative characteristic. I hope you're understanding. I'd put a bar over it so that its mantissa is kept positive. Now pay attention to this part. Its characteristic is 5. Technically it is -5, but numerically it is 5. Now what is the significance of 5? Pay attention to this part. How many 0 do you see after decimal before any significant digit came? Significant means any non-zero. Ari Varasu. I hope I'm pronouncing your name correctly. So I am saying that before any significant digit and after decimal, there are 1, 2, 3, 4 zeros. What is the numerical value of its characteristics? Sir, its characteristics numerical value is 5. So there will be 5 minus 1 zeros after decimal and before any significant digit. Are you able to digest all what I'm saying, first of all the participants, or have we made it very much complicated? I'll try to come up with one more example so that you get more clarity on this. Let's say there is a number. Let's say there is a number log n. Of course, at base 10, if its base is not mentioned, it will be 10. And its log, numbers log at base 10 is given as, let's say, -7.08, something like that. Or if I write it in a more proper manner where I'm ensuring that mantissa is kept positive, it is 8 bar 0.67, something like that. So this 0.67 will be its mantissa and 8 will be its characteristic. Everybody getting this? So here, if I ask about this number n, and if I ask you how many zeros will be there right after the decimal and before the significant digit. So you will say that this number could be of this category. This n could be of this category. Which category? 0.0000000, and then there could be 2 or 3 or 4, something like this. Why am I saying so? Because its characteristic is 8 or -8. Its numerical value is 8. 8 minus 1 is 7. So before any significant digit and after the decimal, there will be 1, 2, 3, 4, 5, 6, 7 zeros. Give me a quick update on this. Is it understandable? Is it making some sense? Are you able to digest all what I'm saying? All the participants? Give me a quick update on this. I'll try to make you understand this entire concept with one of the examples here. First of all, I hope this concept is very well understood by you all. Let's get this concept more clearly. Yes. Okay, great, great, great. We are glad that it helped you. That's good, Buji. So with that, when we talk about this question, again, shall I give you 2 minutes time? So it is 7-4. You have 2 minutes. Try this. Try this. You have 2 minutes. You have 2 minutes time. And once you get the answer, do write your answer in the chat box. That's good. Good to have you all. Keep responding and tell me what do you think will be the answer to this question. Again, try and use the concept of characteristic in mantissa. You may have to use calculator if you want. Then of course with that you'll get the final answer. So tell me what would be the value here. Of course, one property of logarithm will be used here, which you may not be aware of right now if you are watching this session on logarithm for the first time, but still you can do this. Anyone who's willing to answer this question? What are we asked? The number of digits in 6 to the power 20. The number of digits in 6 to the power 20. Now that's a number. Great. How do we figure it out? Let's say the number is 6 to the power 20. So I'm treating n as 6 to the power 20. Cool. So by some means, if I could find its log, by some means, if I could find its log and if I could see its characteristic, I think I could tell you the number of digits in this number. Are you not understanding how useful it is? So in JEE, let's say you see a question where the number of digits are asked in this number. So with logarithm, you can get it very quickly. You don't have to calculate 6 to the power 20, which humanly it is impossible because it will take a lot of time. You try to do it with higher powers of 6, even with 6 to the power 6, you'll start getting amazingly large values. So all I'm saying is that here, let's say that number n is 6 to the power 20, right? I'm trying to take its log. So I'm trying to take its log, which means log of n at base 10. So here if I try to take it, I'm saying log of 6 to the power 20. So there is a property of logarithm which we'll discuss in the upcoming slides, that here, if there is a power 20, that can be brought here, which means I can write it as 20 times log 6. I repeat, there is a property which we'll be discussing in the upcoming slides. Log m to the power n can be written as n log m. Everyone comfortable with whatever I'm saying here? I hope it is not very much confusing. With that, one more property we'll be exploring, which is log of mn at base 10 can be written as log of m plus log of n, where m and n both are positive. Where m and n both should be positive, because we know, I hope you remember, we take logarithm of only positive values. Do you remember that? So with that, when I go ahead, log 6 I'll be writing as, I hope you're understanding, log mn. So 6 is 2 into 3. So 6 is 2 into 3. I hope we can use that property. Which property? 20 times log of 2, 20 times log of 2 plus log of 3. Everyone comfortable with that? I hope you have the value of log 2, you have the value of log 3. Everyone getting this? You do have the value of log 2 and log 3. So if I simply add it, 301 and 477, can we do it quickly here so that we don't get any error? So this is 301 technically. 301 plus 477, which we could have done clearly without calculator also, 778. So it is 20 times 0 plus 778, but there we need calculator, we need to be more precise. So just 10 times of it and then double it. So 0.778 when multiplied with 20, there are some short techniques as well, is going to be 15.56. This is going to be 15.56. Now pay attention to that part. Great. So Rags has already answered. That's brilliant. That's brilliant. So with that, all I'm trying to say here is that this is log n. This is log n. That's brilliant, Rags. That's brilliant. I hope you got this, that this is 15. This is log of n at base 10. So when this 10 is raised to the power 15, there will be 15 plus 1. Are you getting it? Digits in that number n. Because this 0.56 wouldn't contribute in deciding the digits. It will contribute in deciding that number. So here I hope you're understanding it very clearly that this number is going to have characteristic, I hope you're understanding, is 15. So characteristic plus 1. So characteristic plus 1 means 15 plus 1. That means there will be 16 digits in 6 to the power 20. And it will be purely integral. There will be no decimal part in this. So 6 to the power 20 will have 16 digits. Amazing it is, isn't it? With logarithm, without even knowing 6 to the power 20, I could tell you that what could be the value, what could be the number of digits in 6 to the power 20. Interesting, is it? It is, isn't it? Just tell me that. Are you not finding it very insightful? Are you not finding it very amazing? With that, again, this is another question where I need your help. Where I need your help. Do tell me what could be the answer to this question. Again, I'm giving you 2 minutes time. So in 2 minutes, try this and tell me What could be the answer to this question? If you want, you can use calculator right now at this stage. We just want to be quick. We just want to understand the concept. And with that, we'll be moving ahead. So try it. You have 2 minutes time. And then we'll be discussing its solution together. Quickly, I'm waiting for your responses, students. Anyone who's willing to answer this question, first of all, understand the question. Be very careful with the characteristic and mantissa part. Don't commit any error there. And there you'll get the final answer. Okay, Rags. I hope nobody is using AI or Google Lens. You all are doing it by yourself. That's brilliant, Rags. That's brilliant. No, that's regarding the previous question. What could be the answer to this question? Anyone? Shall we start doing it together? So if I again begin with this question, number of zeros between the decimal point and the first significant digit. I hope you remember the property here of this number where log 2 and log 3 are defined. So let's say the number I'm taking as 0.036 whole raised to the power 16. So if I take logarithm on both sides, what do I get? So if I take logarithm on both sides, n here, or rather log n will be 16 times log of 0.036. Comfortably getting it, everyone? I hope there is no confusion on that. Here, if I wish to write it more properly, can I not say that if this decimal is removed, it will be 1 followed by 3 zeros? Everyone comfortably understanding this? If decimal is removed, there are 3 digits, so 1 followed by 3 zeros. It is 36 upon 1000. It is 36. It is 36 upon 1000. So there is one more property which we haven't discussed so far, but you must have heard it somewhere, that log of m upon n can be written as log of m minus log of n, where again m and n both should be positive. Which means what? If I wish to rewrite it, I'll be rewriting it as 16 times log of 36 minus log of 1000. Log of 1000. And I hope I need not tell you, if the base is not mentioned, it is 10. So here, if I rewrite this whole part clearly, this is 16 over here. Log 36 is 4 into 9. Log 36 is 4 into 9. So log mn is log m plus log n. Do you remember that property? So I'll be writing it as log 4 plus log 9 minus log 1000 at base 10. Can you help me with the answer to this question? 10 should be raised to what power so that it could be 1000? So it will be 3. Or if you don't remember, 1000 can be written as 10 cube. Cube comes out. Log 10 base 10 is 1. So the answer will be 3 here. Did you get that part, or shall I repeat this, all the participants? From here, log 4. I hope you're understanding this is 16. Log 4, this 4 I could have written as 2 square. So this 4 I could have written as 2 square. This 9 I could have written as 3 square. So this 2 and this 2 comes to the front because of the property. So this will be technically doubled. Because 2 log 3, 2 log 2. So 2 is taken common. Now we have log 2 and log 3 again, which is what? 8, 7 and 7. Because 3 plus 4, 7, 7 and 8. So 7, 7, 8. So it will be 2 times 0.778. I hope you remember that. Minus 3. So if I perform this entire calculation, where I may need some, you need to use calculator because I want to be more precise. This is the value here. This is going to be the value of log n. So 16 is what I'm keeping outside. So first of all, 0.778 times 2 whole minus 3. So this will be minus 1.44. This is what I get. And minus 1.44 when multiplied with 16, you get minus 23104. You get minus 23.104. Now pay attention to this part. Do you remember we did discuss something very crucial and amazing here, which means what? First of all, here there is a problem. That's good. That's good. 24, no, 23. Correct it once again. 23, 24 or 25 or 22. What will be the answer? Now here, first of all, the moment you get negative characteristic, which is minus 23, of course, I'll be adjusting mantissa and then I'll get this some other value here. Sir, one more question. Do Priyas batch cover from basics to advanced? Yes, yes, yes. First lecture will be on basics of mathematics only, Victor, and we'll cover it in time. Cover it in time. Definitely. With adequate amount of practice. Definitely, Victor. Now with that, when I move ahead from here, what I see clearly is something really amazing. I hope, first of all, to adjust it, I hope you're understanding what is it. let me do that part which you need not do, and I'll show you that this here is giving you the final answer. Let's say this is minus 23.104, right? This n, log of n at base 10 you're receiving as minus 23.104. So what I'll do is minus 23 minus 1. Let me just write that part. Minus 23 minus 0.104. This is what it is. But we remember characteristic could be negative or positive, but mantissa is always positive. So to adjust that, I'll have minus 23 minus 1 plus 1 minus 0.104 minus 0.104. So this part will make it positive and this part will make it minus 24. So this will be minus 24 point something, which means it will be 24 point something. So now we know the characteristic is 24 numerically. Now, what did we just discuss? I hope you do remember the property that here from characteristic, let me take you back to that property. I hope you do remember this property. Here, we did discuss that characteristic. I hope you remember this is the characteristic 5. And with this characteristic 5, minus 1 will give you the number of zeros. So all I'm is saying that before this 5, it was 4 only in terms of the actual value which we have received, minus 4 point something. So if that minus 4's magnitude, the numerical value is taken, that is the number of zeros. That's what I'm saying or trying to make you understand here, that here, if this was the number, log of n, which is minus 23 point something, so its characteristic is going to be 24 because I'll keep the mantissa to be positive. Numerically, it will be 24. So with that 24, I hope you are understanding, minus 1 I'll do. So when I do the minus 1, I hope you're understanding, I'll again get back to 23 only. So that's why I was saying that this 23 is your answer. This 23 is your answer means if you find its value, then after decimal, there will be 23, there will be 23 zeros before any significant digits. Yes, 23 will be the answer. First of all, did you get the logic? So you need not go into this. Stop there and mark this 23 as the answer in that case. Did you understand both of the cases with characteristic and mantissa? Are we clear on that now, all the participants? Can I move ahead from here? Everybody with me on this? Now, let's talk about few properties which I have been mentioning or discussing. The first one being that yes, log of mn at base a is log m plus log n at the same base. But students make a mistake here that the moment you see log m plus n, I don't know why, write it as log m into log n. No, that's not the property which we have discussed. The property which we are discussing in this, and this is all because of the exponents. I hope you remember with exponents what we see, that a to the power x into a to the power y is a to the power x plus y. So this property is getting derived from this only. I hope you are able to understand or digest it or make some sense out of this. But there, do remember, m and n both should be positive. Regarding base, I need not tell you, it should always be positive, not even 1. With that, I hope you remember, if log of multiple values is taken, then log of x1 plus log of x2, log of x3 until log of xn, but there, all of these x1, x2, x3, xn should be positive. The second conclusion. Here, this clearly indicates this property which is written in the mathematical format, which need not be explored right now. Log of m by n, as we have discussed, log m minus log n, and again I need not tell you now time and again that this m and n should be positive. Similarly, this property log m to the power alpha at base a. Do you remember that? We have just discussed that this alpha should be brought to the front, and with that it will be alpha log m base a. Yes, Mr. Rajput, hello, whatever you're writing. With that, when you talk about the next part, this is something crucial. Pay attention to this. I'll simply explain this. That let's say if you have log 2 at base 3 to the power 5. So, sir, are you saying that this base 3 is raised to the power 5? The reason is pretty simple here, that if you use this one, a to the power x upon a to the power y, then it will result into a to the power x minus y. That's why you're having this property. I'm not delving deeper into the reason, the complete proof, but I hope you are making some sense out of it. Exponents and logarithms are inversely related, so that's exactly you're having these properties. Are we clear on this? Now here, all I'm saying is a log of 2 at base 3 to the power 5. So if this 2 is raised to some power, that power comes out as it is here. But here pay attention to this part. If this 3 is raised to a power 5, then if this 5 is removed from here, it will come out as its reciprocal. Did you get that part? So all I'm saying is that if you now simplify this property here, it will be log 2 only at base 3, but base 3 has power 5, which when brought to the front becomes 1 by 5 or makes it 1 by 5. Everybody got this. Everybody understood this. All the participants. Can I move ahead from here? I hope you are making a complete sense from this property that here all I'm saying is log of m add base alpha to the power beta. So this beta will come out at this reciprocal 1 by beta log m at base a. Did you all get that? Everyone? Second property. Let's say if in a question I wish to have log on a different base. Let's say I'm given log 3 at base 2, but we don't want it at base 2. We, let's say, as per the requirement of the question, we want it to on the base 5, let's say. Once again, tell which property is giving. Log 3 base 2, let's say I wish to have at base 5, let's say, for a while. So the basic standard property says a simple conclusion that you take this log 3 at base 5, then divide this by this log 2 at base 5. Everybody got this? I'll re-explain this previous property which some of you may not have understood. All I'm saying is that log of, let's say, 20 at base 2 to the power 10 is needed to be taken. All I'm saying is that this 10, the base to the power something, when it is needed to be resolved, this power comes out, but its reciprocal comes out. So it will be 1 by 10 log of 20 base 2. Is it understood by everyone now? All the participants, those who were asking it to be re-explained. I hope this part is also very well understood that if I wish to change the base, log m at base b, but I want it to be on base a, so it will be log m base a divided by log b base a. Everybody got this conclusion? All the participants, are we clear on this? Can I move ahead from here, all the participants? Now with that, when I go ahead, what is next? Yes. These are some conclusions. Do remember that let's say if I have log of 7 at base 5, then I can unhesitatingly write it as 1 upon log 5 at base 7. Why and how? Let's say this is log 7 base 5. So can I write it as log? I hope you're understanding. I want it to be at base 7. So log 7 base 7 upon log 5 base 7. Log 7 base 5, if I want it at the base, how 5 came in that fifth part? Which fifth part, students, are you asking? Any desired base. Uji, I'm saying any desired base you can have. Let's say if you want to have, base 10 for a while. So instead of this 5, you could have had any base, whichever base you want. So as per the need of the question, we may want to convert it into some other base. So there all I'll simply do is that here log 3 base 2 is given and I want to convert it into some other base, let's say log base 10. So I'll write it as log 3 base 10 upon log 2 base 10. That's exactly what I'm trying to do here with this part where I'm saying that it is log 7 base 5. It is log 7 base 5. So let's say I want it to be at base 7. So how will I convert or get it at base 7? I'll simply write this log 7 at base 7 and this log 5 at base 7, and we know that log 7 at base 7 is 1, so my final value will be 1 upon log of 5 at base 7. Did you all understand it now, all the participants, or shall I re-explain this? Everybody got this? I hope no confusion on that. So here all I'm trying to make you understand is that one more property comes into picture, that log a base b will be 1 by log b base a. Which means, let's say if I have in a question, let's say log 7 base 10. So if I needed to write it, I wouldn't hesitate in writing it as log 10 base 7 if it is needed as per the requirement of the question. That's great. That's great. Can I move ahead from here, all the participants? Now from here, when I go ahead, these are not the properties, they are simply the conclusions which you can simply understand by having this idea of converting it into the desired base. What does it mean? Let me explain any of these. Let's say I explain you this one. So log a base b, I hope you're understanding log a base b, I can write as log a by log b, log a by log b at base 10 both. So if not mentioning base, it means the base is 10. Log b base c, I'll be writing as log b by log c. And here, log c base a, I'll be writing as log c at base log a. Now, what am I getting from here is clearly log a getting cancelled, log b getting cancelled, log c getting cancelled, so it will result into 1. So this is not a property technically, but you've got to understand that this is how you deal with questions based on log. Are we clear on that? Now, there comes again a very interesting property with which we had begun this question session. The property, the fundamental property of logarithm. Let's say if somebody asks you e to the power ln a to the power x. What does it mean? I rewrite it. E is your base raised to the power ln a to the power x. Now, what is ln? Log at base e. So, I hope I can write it as e to the power log of a to the power x at base e. Now, do you remember the fundamental property of logarithm did we discuss? I hope you remember. We did discuss this very clearly that if you see this base and this base to be same, then your answer is this value. Do you not remember this property, fundamental property of logarithm? So with that, will I not say that my answer here will be that if this e and this e are same, my answer will be a to the power x. That's exactly what they have written over there as a result, as a conclusion. All the participants. So log c by log b, right? Which part are you asking? I repeat, this can be written as log a by log b. This will be as log b by log c. And this will be log c by log a. And things will get cancelled and you'll get 1 is the answer. The same you can perform or do for this as well. Everybody with me on this, all the participants. Let me do this part as well so that you get more clarity on this and you don't get confused with this. This next part, this third property also I'll explain. Log x base y. Can I write that as log x by log y? Into log y base z. Can I write that as log y by log z? Into this log z base a. Can I write that as log z by log a? Now you can have any base, base 10, base e, base 5, base 3, whatever base. Of course, base should always be positive and not 1. So with that, when I now simplify this, I hope you can see log y, log z cancelled. So I'm still left with log x by log a. So I hope you know that from this property only, which property? The property we discussed in the last slide. This one, from this property only, log x by log a. Both are at base 10. So I can write it as log x base 10. What is ln? Bujji, as we have discussed, ln is nothing, but let's say if it is ln x, then it is nothing. Log x at base e. E is your Napier's constant, 2.71. Everybody with me on this, all the participants, can I move ahead from here? Are you getting it comfortably? With that, when I go ahead or talk about few more properties, now there comes the more interesting properties. And they are more intensive, they are more profound, they are more deeper. How? Let's begin with this one. This is again that fundamental property only which we have discussed. Now, what does this property say? If I could explain you this property here, let's say if I'm told 2 to the power log, I hope you're understanding, 2 to the power log 7 at base, let's say 3. 2 to the power log 7 at base 3. So this 2 is your base. This is raised to the power log 7 base 3. Always remember this as a result, that this 2 and 7 can be swapped. This 2 and 7 can be swapped, which means it is always equal to 7 to the power log 2 base 3. Are you getting the conclusion I'm trying to give you here? All I'm saying is that this 2 and 7 can be swapped and it does not lose its value. It always remains same. That's exactly what you're told here, that I hope no confusion on that conclusion, that a to the power log x base b. So this a and x can be swapped, which means it is equal to x to the power log a base b. Will you remember that result? Will you all remember that result? Now let's say I give you a simple example and ask you what will be the answer here. Let's say I ask you 3 to the power log 10 at base. Let's say instead of 3, it is, let's say, 9. So 9 raised to the power log 10 base 3. What will be the answer in that case? Can you answer that question? I'm just asking you a simple question. 9 raised to the power log 10 base 3. So all the participants, Yes, Bumble Boto. Ln is natural log. Why do you keep your names like this? To make us laugh? So here, 9 raised to the power log 10 base 3. If it is your name, then I'm really sorry. 9 raised to the power log 10 base 3, what will be its value? Do tell me. So as we have just simply clearly discussed that this 9 and 10 can be swapped. I hope you do remember. So if this 9 and 10 can be swapped, I can write it as 10 raised to the power log 9 at base 3. Do you remember that? With that, this 9 is nothing but 3 square. So can I write it as 10 to the power log of 9 I'm writing as 3 square at base 3. And if it is 3 square, I can bring this 2 to the front, log m to the power n log m. I hope you remember that. So this will be 10 to the power log of 3 base 3 and this 2 comes to the front. Yes, brilliant. That's good. And I hope you remember log a base a is 1. We did discuss. So this will be 10 to the power 2 into 1. So your answer will be 100 to this question. So 9 to the power log 10 base 3 is clearly nothing but 100. So one of the ways of writing 100 is this. So in JEE, they may test your this understanding of this property, and instead of writing 100 in an expression, they may give you this value. And with that, you got to convert into 100 like this. Will you remember this property, all the participants? Are we clear on this? Everybody with me on this? With that, let us discuss few more. Few more means this one. The next one, I hope you all are there, listening, watching, and understanding clearly all the properties. So if I could talk about the next one, can you see the next one, students? This one. A to the power log x base a. That's good, 100. That's good. A to the power log x base a. What would that be? I hope you are clearly noticing that this a and x can be swapped. With that, it will be x to the power log a base a. It will be x to the power log a base a. And log a base a is 1, which means x to the power 1. That's your answer. With these conditions, which I'm not mentioning time and again. So these are the conditions which are there, which are understandable now. The next case, log x a to the power k, as we have simply discussed, k comes to the front 1 by k. Here there is another case where students commit a lot of mistake. Let's say it is log of x to the power, let's say 8 at base, log of, let's say, I'm trying to create this property I'm trying to make you understand. Log, let's say, x to the power 8 at base, let's say 10. So if I now wish to bring this 8 to the front, you can, which will be 8 log x base 10, but it is unfortunately false. Because there is a catch, this x could have been negative as well. And negative raised to the power even is positive. So there my problem is resolved. We are taking logarithm of something positive. But if x was originally negative, then I cannot take log of any negative value. So there I got to keep it non-negative. So how do I keep it? I put a modulus over there. So whenever you remove an even power from a variable, from a logarithm like this, you got to put a mod over this. Is this point understood by you all, or shall I re-explain that? Similarly, if I take you towards this property that also uses the same concept, what does it mean? Let's say if I ask you this property, which means log of, let's say 7 at base alpha to the power 10. So we do remember that base when raised to a certain power, that power can be brought to the front, but it will be its reciprocal. So I could write it as 1 by 10 log of 7 at base alpha, but that is again wrong because alpha is a variable. So alpha to the power 10 would have been positive. The base is always positive. But here, if alpha's power 10 is removed, then this alpha could have been either negative or positive. But if it is negative, the base of log cannot be negative. So to keep it positive, I'll put a mod over here like this. Are these properties understood by you all that you should be cautious like this? So when you talk about JEE Advanced, there these properties come into picture. That awareness come into picture. This understanding comes into picture. Are we clear on that, or shall I re-explain that part? Can you help me with one last thing? If I were to ask you that what could be the value of this expression, let's say log of let's say 10 to the power 4 at base 10 to the power 3. What will be your answer in that case? I hope no confusion. You can directly write the answer that this power 4 comes to the front as it is, but this 10 to the power 3 comes to the front as its reciprocal, and then you're left with log of 10 base 10. and log of anything at the same base is always 1, so your answer will be 4 by 3. But you need not solve this entire expression by looking at this only. You could have directly said that this 4 by 3 will be the answer. Are you all comfortably understanding all what is being said, all the participants? Can I move ahead from here, everybody? Now with that, when I go ahead, let's talk about few more properties. Please remember, there is again a catch, based on the same property, that log x square is not 2 log x, it is 2 log mod of x. Because again, x could have been negative or positive, but here x, if it is negative, log is not defined. So I got to put a mod over here. So that's how things vary. That's how things vary. Everybody with me on this? These are some conclusions based on that only, which I hope not require much conclusion. But here, when I talk about inequalities based on logarithm, I'll explain it with some simpler examples. I hope you do remember. Let's say if I get back to the previous slide only here, let me just take this example only. Which one are we explaining? This one we are discussing right now, right? So this one we are discussing right now. Now pay attention to this part. Let's say if base is greater than 1. If base is greater than 1, let's say I'm talking about log of 20 and log of 30. So I hope no base is mentioned, which means base is 10. If the base is 10, let's say the base is there, let's say A. And if base is mentioned, that base is greater than 1. This base plays a very crucial role. Now pay attention to this 30 and 20. Which is greater? Sir, 30. Then if the base is greater than 1, then you can always say that sir, log 30 will be greater than log 20. Are you getting it? Again, if I ask you log 20 at base A, log 30 at base A, and if now the base is less than 1, do you remember? Sir, if base is between 0 to 1, less than 1 means I'm clearly saying that base is from 0 to 1. So I hope you do remember, if the base is from 0 to 1, your function log becomes a decreasing function. And if it becomes a decreasing function, then the inequality changes, which means if 30 is greater than 20, then log of 20 will be greater than log of 30. Do you remember that discussion? Do you all remember that discussion? Just give me a quick update in the chat box, in the comment. Did you all get this? Both of these properties. And why is it happening? Because log x is a strictly increasing function if the base is greater than 1, but if the base is from 0 to 1, it is a decreasing function. And because of that, the sign changes. Are we clear on that? Similarly, this conclusion is pretty simple. Opposite of means, let's say if I'm given log of x greater than log of y, right? Log of x greater than log of y. But in this case, let's say the base is 7. In this case, the base is 0.3. First of all, the base should be same on both the sides. So here again, when the base is greater than 1, the sign which is there between them, the same sign will be there between x and y, which means here I can conclude that x will be greater than y. That's exactly what is being told, that if log x is less than log y, so x will be less than y if base is greater than 1. But if the base is between 0 to 1, then the sign changes, which means log x is greater than log y, then x will be less than y. The sign changes. Why? Because the base is between 0 and 1. Will you remember these basics? I hope you clearly see log x is less than log y, but x is greater than y if the base is between 0 to 1. Are we clear on that part, everybody? Can I move ahead from here? Just give me a quick confirmation on that. Similarly, there are few more conclusions. What are they? I'll simply now introduce the concept of anti-log first. What is the concept of anti-log? Let me take you through that. I hope you're understanding. If I am told log of m at base a as n for a while, let's say. So what we know clearly is that, sir, this a raised to the power n gives you m. So this a raised to the power n gives you m. This is nothing but taking the anti-log. So if I take log here, that means this. If I take anti-log here, that means this. So process of, taking log is taking logarithm. So removing that log, which means inverse process of log, is called anti-log, anti-log, however you wish to pronounce it. Are we getting that? Which means if I now talk about these properties which are being mentioned here, let's say log x is greater than p. Let's say I'm given log of x at base a is greater than 30. This is what I'm given. So let's say had there been an equality, I would have said a to the power 30 is x. I would have said a to the power 30 is x. I would have said a to the power 30 is x. But again, there is a catch. Sir, what is the catch? Now, there is not an equality. This is an inequality, which means either greater or lesser. So, again, it depends on a. Sir, if your base a is greater than 1, if your base a is greater than 1, then the sign remains same. I hope you're getting it now. And if the base is between 0 and 1, then the sign changes. If it was greater, it will be lesser. Is it making some sense now? Are you able to digest these properties? And that's exactly what they ask you to solve when they give you questions based on logarithm and inequalities. And JEE does ask questions based on that. I'll show you, I'll demonstrate you. Similarly, if I talk about this part, which is an extension of this only, no need to be explained that part. If I talk about this, this is again that extension only, which we have simply discussed. Now, I think this also we have clearly discussed. I need not. This is for JEE also. Nicholas Tesla. This is for JEE only. I am Deependra, Faculty of Mathematics of IIT JEE Mathematics, teaching you or taking you through this bridge course. The students of 11th class moving into 12th class who may have missed some concepts of 11th standard, which are amazingly crucial for your 12th standard, are being taught into this bridge course. So if your comment asks that is this for JEE also, I would say this is for JEE only right now at this stage. But some medical aspirants can use this logarithm in chemistry. Some NEET aspirants may use it in, of course, chemistry, or some other student may use it in some other chapter, somewhere else in mathematics, CAT aspirant or some other aspirant. But here, all I'm saying is that if you are a JEE aspirant, then this is session specially for you, Nicholas Tesla. Have I cleared your doubt or query? Are you not reading this line, logarithm complete class 11 maths in one shot? Why have they given this complete class 11th maths in one shot? No, it is not complete class 11 maths in one shot. It is logarithm in one shot, this bridge course. Okay, moving ahead with this, let me talk about these properties. I think I need not give you clarity on these. This you can understand through graph only. We have discussed graphs in a very, very, very detailed format. Again, should you learn them? No, no, absolutely no. But should you understand this? Yes. How? Let me try and give you clarity on that. Please pay attention to this. Sir, A and P both are greater than 1. If A and P both are greater than 1, A means base. So the base when is greater than 1, this is how it happens. Let me just copy it twice because I'll be needing it at two places. Then I'll be explaining it. So if I get back to the discussion over here, I repeat, sir, when base is greater than 1, when base is greater than 1, this is the graph of log x at base A. I hope you do remember that. And I hope I did not tell you this point over here is 1, 0. Now, when A and P, sir, integration when we do? Parnika, integration is a chapter of 12th standard. So that will do in 12th standard. This is the bridge course for students moving from 11th to 12th. So we are revising the chapters of 11th standard. Not all the chapters, the chapters which are more needed in 12th. For example, logarithm, inequalities, sequence and series, quadratic, right? Now, if I get back to the discussion I'm having, I'm saying that P is greater than 1, which means any value on the right of this, which means let's say I've taken this value. So this is log of P at base A. So when A is greater than 1, this is how you see the graph of log x drawn. And when P is greater than 1, that is where you find log P. So if this is log P, I am clearly seeing log P to be lying on the positive side of y-axis, which means log P base A will be positive. So all of these you need not remember. You can simply visualize it like this in the graph. Just tell me which one do you want me to explain, any of these. Let's say you want me to explain this one, fourth one. Now, how do we go ahead with this fourth one? Pay attention to this. The fourth one. Any of these you can understand through simple understanding. First of all, a is greater than 1. So again, if a is greater than 1, your graph of log x will be drawn like this. So this is the graph of log x at base a, where a is greater than 1. Great, perfect. Everybody with me on this? Now, what are they saying? They are telling you that, sir, p is greater than a is greater than 1. So p is greater than a. P is greater than a. Now, a is greater than 1. So a, if it is greater than 1, you take any value, let's say 1.5. So p is greater than 1.5. So p is greater than 1.5, which means p will be on the right of this. Let's say p is here, which means this will be log of p. So it is again positive because it is on the positive y-axis. So that's how you can talk about any of these. You write in the comment box whichever you want me to explain. I'll definitely explain. Luckily, Buji, I have already explained the fourth one. I hope you got a decent clarity on this. Are we comfortably understanding all these properties? Can I move ahead from here, all the participants? These graphs we have already gone through. I'm just keeping them in the notes so that when you revise, you understand them. All of these we have already discussed. I hope you do remember them very, 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 very clearly. Yes, this transformation of graphs we'll understand when we study the chapter functions. There I'll take you through a topic, transformation of graphs. Don't worry about that. So there I'll be making you understand how do we draw the graph of log of mod x or mod of log of mod x. All of these I'll be explaining you there, but I'm keeping it there in these notes so that when you receive these notes, you can have them. I hope you know how can you have these notes by simply logging on pw.live or having our app. There in this free bridge course, you can have these notes, these PDFs, these structured notes at your fingertips. Now moving ahead with this, these all will be understanding when we talk about functions. This GIF also I'll explain there, but right now I'm not explaining this. Now, can you help me in answering this question? So you have 1 minute's time, solve it and tell me what could be the answer to this question, all the participants. If I could explain this along with you when you're solving this. Log x, log x, log x, log x. So x is there, but what is the problem? So the problem is base. Base is 2, 3, e and 10. I hope no confusion on that. Now there are two things. Sir, once x is greater than 1 and the other time x is between 0 to 1. So there are two ways of solving this. One of the ways is, first of all, do tell me, do you remember the property which we did discuss when I told you that, I hope you remember, that log a base b can be written as log b base a? Do you all remember that property? Log a base b can be written as, sorry, I'm really sorry. Where is my mind today? It is written as 1 upon log b base a. Give me a quick update on this. This is how we write it. So here, if I wish to change this question a little, can I write this as log x base 2 as 1 by log 2 base x, this as 1 by log 3 base x, this as 1 by log e base x, and this as 1 by log n base x. Give me a quick update on this. Are you all there with me on this? Everybody with me on this? I hope there is no confusion on whatever I've said so far. Now when I talk about this expression, the denominators, pay attention to them. X, the base is x. The first case I'm solving, when x is greater than 1, forget these numerators, I will introduce them later. I hope you remember, when x is greater than 1, whatever is the relation between 2, 3, e and 10, whatever is the relation between 2, 3 and 10, that same relation will be there between their logarithms, which means if 2 is less than 3, log 2 will be less than log 3. If 3 is less than e, because I'm really sorry, e is your log 2.7. E is your log 2.7. So 2.7 is less than 3. So log e base x will come here and log 3 at base x will come here. I repeat, because e is 2.7. So 2.7 is less than 3. So log e will be less than log 3 because base is greater than 1. Similarly, 3 is less than 10. So log 3 will be less than log 10. But that's not what you are asked. You are asked the inverse of it. So when you take the inverse, the sign of the inequality changes, which means, I hope you remember, 1 by log 2 base x, 1 by log e base x, and 1 by log 3 base x and 1 by log 10 base x. So if they were in the ascending order, their reciprocals will be in the descending order, which means this will happen. Everybody getting this? And if I now talk about this property, that how do we write as 1 by log 2 base x as, then I have to remember I can write it as log x base 2, simple property, greater than log x base e, greater than log x base 3, greater than log x base 10. Give me a quick confirmation and update. Did you all digest this, or shall I re-explain this part? All the participants. Everybody with me on this, or shall I re-explain this quickly? Give me an update on this. All the participants. Are we all there? I hope there is no confusion on that, whatever I've explained so far. Sir, what if the base is between 0 to 1? So when base is greater than 1, if this is the order, when the base is between 0 to 1, the order changes. Least, greater, greatest. Are you understanding the second part? Shall I re-explain that part? I repeat, this is all happening when base is greater than 1. So if base is between 0 to 1, this order will change. Less than. Which part do you want me to re-explain? Which part? I'll explain the second part of this question, and once again in the same manner. First of all, log x base 2 I have written as log 1 upon log 2 base x. Log x base 3 I have written as 1 upon log 3 base x. Log x base e I have written as 1 upon log e base x. And log x base 10 I have written as 1 upon log 10 base x. Everyone comfortable with that? This entire part I'm explaining that. Now let's talk about this. Log 2 base x, log e base x, log 3 base x, and log 10 base x. Please help me with this. Please help me with this. I hope you remember, if the base x lies between 0 to 1, the sign changes, which means here, if 2 is less than e, log 2 will be greater than log e at base x, because base is between 0 to 1. If 2.7 is less than 3, then log 2.7 will be greater than log 3 if this base x is between 0 and 1. If 3 is less than 10, log 3 will be greater than log 10 if base is from 0 to 1. Do you remember this inequality, this property we have discussed? With that, what I say next is, if I take their reciprocals, which means 1 upon log 2 base x, 1 upon log 2 base x, 1 upon log e base x, 1 upon log 3 base x, and 1 upon log 10 base x. So if they were in the ascending order, their reciprocals will be in the descending order, which means if this was the greatest, this will be least, then this will be the order. I hope you understand. 2, 3, 4, 5. Then 1 by 2, 1 by 3, 1 by 4, 1 by 5. The order changes. Are you understanding what I'm saying? And there we did discuss this property students, that log b base a can be written as 1 upon log a base b. So if I use that property here, I hope you are clearly getting this conclusion, very clearly getting this conclusion. 1 upon log 2 base x can be written as log x base 2 less than 1 upon log e base x can be written as log x base e less than equal to log x base 3 less than log x base 10. But this will be true not in the first case, in the second case, when base is between 0 to 1. Great. Everybody with me on this? Everybody understood this explanation? Can I move ahead from here? This we have already discussed. I hope we can move ahead with this. Now there comes the final question for the day. If you could solve this within 2 minutes, I'll be really happy, and I'll find myself to be successful in conducting this session. The final question of your logarithm. If you could solve this, I'll be really happy. I'll be amazingly happy. Tell me, what do you think could be the answer to this question? Anyone? I'm waiting and hoping for your answers, all the participants. All what we have learned so far could be applied here. And yes, the learnings from the previous session where we have discussed inequalities, they'll also be applied here. Log x minus 2 at base 2 less than log x minus 2 at base 4. First of all, the base are not same. If the base are not same, I got to make them same. So here it is log x minus 2 at base 2, perfectly fine. This is log x minus 2 at base 4. This 4 can I write as 2 square? Are you comfortable with that? So if base is raised to a certain power, that power comes to the front with its reciprocal, which means if this is 2 to the power 2, I can keep that 2 here, but that power 2 will come as 1 by 2 here in the front. Give me a quick update on this. Are you all getting this? Now this 2, if I multiply both the sides of this inequality by 2, you're okay with that? So here it will be 2 log x minus 2 at base 2, 2 by 2 is 1, less than log x minus 2 at base 2. Now there is a problem. Which problem? This 2 if I take there, I am creating the problem or the possibility of root gain, which we discussed in the last session. Do you remember that? Root gain, root loss. If you have watched the last session, you may be able to recall that. If I'm squaring it, then I'm creating some problem. Although that problem can be resolved by matching it with the actual question. I'll try and tell you again with this example. Just pay attention to this part here. I hope you understand log of x minus 2 and this is 2. So this 2 can be raised as a power here. So when I take this 2 as a power here, I can write it like this. Now pay attention to this part. This is log 2, this is log 2. The base is greater than 1. This is base 2. So base 2, I hope your understanding is clearly greater than 1. So if base is greater than 1, the sign of the inequality doesn't change, which means this value, which is x minus 2 whole square, is less than x minus 2. Everybody getting this part or shall I re-explain this? That's good. We'll verify that. Shall I re-explain this part or everybody understood this? X minus 2 whole square will be less than x minus 2 because base is 2 which is greater than 1. Are we comfortably understanding this? Now from here, if I take this x minus 2 the other side, what will I have here? X minus 2 whole square minus x minus 2 to be less than 0. With that, when I solve this further, I can take x minus 2 common. So when I take x minus 2 common, I'll be left with x minus 2 minus 1 less than 0. Correct me if I'm wrong, all the participants. With that, this becomes x minus 2, x minus 3 less than 0. And if you have watched the previous session, there we discussed the wavy curve method. It's not baby curve method. I hope you remember. It's wavy curve method. So even if you don't know that, you can directly solve this. And we have remembered or learned that conclusion in case of two factors that the answer will be between 2 and 3. If you don't remember, 2, 3 plus minus plus. Do you remember that? I need it to be negative, which means minus. That is between 2 to 3. So here I may be thinking that answer could be 2 to 3, but let me cross check it. I hope when I put any value between 2 to 3, it does not violate its domain. Domain means if I take any value between 2 to 3, let's say 2.5. So 2.5 minus 2 will be positive. 2.5 minus 2 is positive. So yes, any value between 2 to 3 will be an acceptable value. So yes, the final answer will be x belongs to 2 to 3. That's good, Bujji. Everybody understood that? By the way, what's your real name, Bujji? Everybody understood that? So now the summary is we have discussed logarithm. This is for all the JEE aspirants. And yes, we are discussing the subjects mathematics, if there is any confusion on that. And this is your bridge course, especially for the students moving from 11th to 12th. We'll be conducting more such sessions, especially on sequence and series and quadratic expressions. And that's how we are concluding it. Do remember, we have launched our Arjuna, Laksh and Prayas batches as well, which are live on our pw.live channel. You can access our application as well. Arjuna is for students who are in 11th standard. Pure English. In Pure English, we are going to teach you that. Laksh is for students who are preparing for JEE in 12th standard. I am Harini. Good to have you, Harini. And Prayas is for those students who are droppers preparing for JEE. So with that, let's meet in some other video. Thank you so much. You have been a great audience. Take a good care of yourself. Good night, everyone.